Okay, so everyone can see the screen. Guys, response.
Yes, sir.
Yeah. Okay. So first things first. This won't be tolerated in further assignments or further works. Okay. See, by using this line, what you have done is you have made your notebook dependent on your particular computer because this is reading it from your local system. You are given the path of your C drive. Okay, where you could have easily got this data directly from the website. This is something which you will notice when you are building data pipelines for much bigger data sets, where you don't have the luxury of downloading the data and keeping it into your system. You have to directly pair your machine learning algorithm with the data repository. Okay, so this is something that take care of this, and if you can use the internet source directly, try to use the internet source directly. Okay, here in this part, this is like your pretty standard stuff that you are going through the data. Okay, fine. Now I think if you had run this, it would have shown. No? It's not showing all output values, no? Just because of that. Hold on. Okay. Data is equal to. Wait. UCI. Housing, no? Oh, wait, not this one. Uh, UCI. Yep, this one. Mm. We still don't have. What was her name? Sindhuja with us, no? Is Sindhuja present with us or not? Windows dot. Hold on. Okay. Should have 13. Okay. What was the keyword for the white delimiter? Okay, wait. Hold on. Delimite space. Now, if we do data, it should give us the 13 columns. Okay. Now, see, just by doing this, I am downloading it straight from this place, not from the system. So now this notebook is system independent. So we can run this, run all. Okay. Now, okay, this one, let's delete this cell for now. Bharadwaj, are you with us?
Yes, sir.
Bharadwaj? Yeah. Now,
Yes, sir.
can you explain these plots?
Sir, actually, sir, these plots are ranges between all zeros, 0 to 1, sir,
Okay.
independently.
And
And for each column, I have plotted this. I have reduced the scale, sir,
okay.
basically.
So
That I am.
what does this density mean? Now, see, suppose I'm looking at these particular plots with double hump. Okay. Like we call these humps as camel humps. Okay, so you have seen no, those Mongolian camels with two humps on the back. So this is kind of
Yes,
a
sir.
Mongolian camel. Okay. Now, what does this mean? This that you have this plot of your second column values between 0 to 20, and it goes almost 60% of your data is aggregated here. Rest of the data is aggregated here. Okay.
Yes, sir.
What can this tell you from this data set?
Here we can see that most of the data is in between. This maximum part is for 0.8, means this over 20 it's their peak, no sir.
See, this tells us that this particular value, what will be? If this is 20, then this will be 10, then this will be 5.
Yes,
Okay.
sir.
So around 60% or around 75% of data has this five values of five value in the second column. Okay.
Yes, sir.
And this says that there are two level means or two blocks in which this second column is distributed. See, this is why I don't necessarily go into plotting that much. It will unnecessarily complex you or make things complicated unless you understand what you are plotting. Okay, this dist plot, unless you know what dist plot is and what this dist plot will tell you beforehand, do not go for plotting. Okay, try to keep things simple so that you can actually find out whatever the problems are. Now, in this one, here you have done maximum and maximum and minimum scaling, correct?
Yes, sir.
Okay, now the problem is that I have deleted your column part, so this part of code won't work.
Yes, sir.
Okay, so let's leave it there now because we'll have to make some changes and that will take time in us. Here in this part again, you are plotting and you're making the same plots. Okay, fine. You don't have to do this values part, just this part will also do the same thing if you go for this part only. Okay, okay, okay. Hmm. So see, you can you explain why you only scaled this four particular rows? Only these four particular rows. Diaz, hello.
Good evening, sir.
Yeah, can you explain why you scaled only these four particular rows, not all the rows?
Sir, actually CRM, Z and TX are having same values until first to last column, sir.
Okay.
That's the reason.
See, come here. Here you have all your 13 columns. Sorry,
Yes, sir.
14 columns. Okay.
14.
In this one, minimum value is 0.06, maximum value is 88.97.
Yes, sir.
Second column, minimum value is 0, maximum value is 100.
100.
Next is minimum value is 0.46, maximum value is 27.74.
27.74.
0 to 1, so this is pretty much scaled.
Yes, sir.
This is also 0.35 to 0.87, this is also pretty much scaled. Okay, see, almost all the columns are unscaled. They have different scales in which the data is distributed. So if you are going for normalization, no, go for the entire data set.
Okay.
Okay, this way you will be able to keep your relation or correlation. You will be able to preserve your correlation.
Yes,
Correlation
sir.
between columns is not necessarily a bad thing. Okay.
That we are keeping just the values in between 0 and 1.
Hmm.
Okay.
Okay, anyway. Okay, got it. Okay.
Yes, sir. Got it.
Okay, so let's move on to our next column. Hold on. Hmm. Who's next? Next, let's go for Raghav. Okay.
Yes.
Raghav, can you hear me?
Yes, sir.
Yeah. So see, okay, you have also gone through the same thing. No null values, similar plots. Okay. Next time if I see a plot in a notebook, I will directly ask you to explain it. Okay. And
Okay.
if you fail to explain it, that will go negative on you.
Okay, sir.
Okay. See, I'm not against plots, but you have to understand what you're plotting. Otherwise, you'll just be making some pretty diagrams, but those pretty diagrams won't tell you anything. Understand what it means. So first of all, think what you're plotting and what you're comparing. Okay.
Okay, sir.
You have also done the exact same thing as in previous notebook. So either both have been developed by the same person, or you have like discussed everything. Here, little bit of difference. Okay. Why are you calculating this externally or like in by your own? You could have just used the score function, no?
Yes, sir. To predict, I mean,
No. So what do you know the difference between model.score and MSc? Hmm? See, I'll tell you the difference. When you are doing this model.fit and model.predict and model.score, no,
yes,
you are using sklearn's score library. Okay, but when you are doing this, you are extracting data from the model, and then you are passing it again to a different instance of the same object. Okay, you are extracting data from one place, you're putting that data to in another place, and then it is getting calculated there again.
okay, sir.
Okay, so this unnecessary transaction, this will cost you time, and this will cost you computational power. This will not cost you accuracy, but it will cost you time and computational power. Okay,
Okay,
when you move on into deep learning, you'll have to take care about these things also, because
okay,
in testing environment, while we are training something in a lab environment, in a designated lab, but when we will use it in the real world, it has to go and it has to be scalable. Correct.
yes, sir.
Okay, so try to use as much as standardized functions as you can, everyone.
Okay, sir.
Okay, now this will tell you some interesting thing. This particular plot. Okay, can you see what?
Sir,
Yes,
most of the values in this graph are in negative, sir. I mean,
most of the values. How?
attributes. Sorry.
You have five negative values, you have five positive values. So negative and positive are almost same,
Yes, sir.
right? That negative and positive are almost same. See what it is telling you.
It will.
The first five values, knock, scream, this, that, these first five values, 0 through 4, okay, they are contributing negatively to
Yes,
your
sir.
model. The first value is contributing a lot. Even in negative also, it has like, it is inversely proportional to your predictions, and it is inversely proportional in a big way. Okay.
Yes, sir.
Second is slightly smaller. Third is a lot smaller. Fourth and fifth are all barely meaningful. Sixth and seventh, they don't matter.
Yes.
They just don't matter to your prediction model. Now, from 8th till 13th, it again it has positive impact.
Positive.
12 and 13 have almost similar impacts. Same goes for 11 and 12,
Yes,
and so
sir.
on and so forth. Okay, but in another notebook, I have seen it in some other students' notebook. We will come to it. In this, you'll see that you have not normalized the data. You have not normalized the entire data set. You just normalized some particular columns.
Yes, sir.
Okay, and this will have some impact. Got it?
Yes,
Okay.
sir.
Okay. Okay. Now let me just move on to some other notebook. Sucheta, are you with us? Sucheta, are you with us? Okay, I don't think she's
Sir,
there.
Sucheta is outside, so she will join afterwards, sir. She wants
She'll
to.
join. She will join afterwards.
Yes, sir.
Okay, I think this was her notebook only, no? She has also done a lot of things. See, she has scaled the entire data set. Okay, that she has scaled this entire data set to the min-max scaler, and because of that, your entire feature importance graph, na, it just changed. See this? If you compare this with your feature importance graph, those are
Yes.
like two completely different things. Okay,
Yes,
so
sir.
this
Negative
is
to positive.
yes. So
My graph was
you
negative to
hmm,
positive.
okay. So and this is the kind of impact that we see sometimes. So not necessarily, it's not necessary that normalization will always work. Okay, but if you are doing normalization, be sure that you normalize the entire data set.
Okay, sir.
Okay, like the scale should be maintained. Next, we don't have Sindhuja with us, no?
Yes, sir.
Sindhu,
She's
you
not
got,
there.
huh?
She is not there, sir.
Is she not there? Aryan, are you there? Aryan?
Yes, sir. Yes, sir.
Sir, Sindhuja is having power cut today, sir. That's the reason she didn't join.
Okay. Aryan, are you there with us?
Yes, sir.
Okay. Now, see, what you have done here is you have converted your data file to Excel file, and then you have read it to read Excel. Now, what this has done is this has created this particular thing, null values. Because you have converted data
Yes, sir.
through like unsecure channels, your data set has become violate, or it has become contaminated, so as to say that you have some external data, either some internal data missing or some external data has entered that value. Once this happens, whatever you do with the data set, that becomes invalid. Okay, so next time whenever you are reading raw data, na, be extra careful that you don't read some noise with it. You have also deleted it. Okay, pair plots in this big data sets are a mistake, as I am sure you could have seen from this, because there's no way you will be able to make sense out of this anyway.
Yes, sir. Yes.
Okay, so
Okay, sir.
don't go for this big confusing things.
Okay, sir.
Okay, okay, okay. Next, who is this there with us? Riaz, I think we have done with your notebook, no? No, we have not done.
Sir, we are not done.
Okay, okay, okay. What have you done here? Can you explain this part?
Sir, we have applied log like first logarithm for the data for the columns, sir, which are like
Hmm.
not in between 0 and 1. We have brought into by applying natural logarithm like
Hmm.
first logarithm. We have
Hmm.
brought into data from 0 to in 1 like.
Okay. So only the columns which are not between 0 and 1, you have brought it into 0 and 1. Those who are already between 0 and 1, you have not touched them.
Yes, sir, not achievement.
Okay.
Yes, sir, we have columns of transform. Have mentioned, no, sir.
Yeah. Now, see, the thing that you have to ensure that does not happen, and the way this type of plotting can help you, okay, is that after normalization, no, the shape of this line, okay, I'm not talking about scale, the shape of this line should be same. Okay, so as you can see here, the shape has almost been consistent, and if you compare this particular shape with this one here, it will give you different values. Okay, now
Yes,
here everything is between 0 and 60.
yes, sir.
Oh, sorry, 0 and 50. Okay. Anyway, like this is sometimes this confuses the hell out of me also. That we don't necessarily always know what which measures to take and which to not. Okay. Okay. Hmm. Uh, can you explain gradient boosting regressor?
Sir,
Explain the algorithm how gradient boosting regressor works over normal linear regressor.
sir, normal linear regressor means like in linear regressions. Sir, one second.
Hmm.
Yes, sir. Hello.
Yeah, yeah, speak.
So normal like in linear regression, we put like in a sense how it is. So,
Okay. Your assignment for next class is that you will learn about gradient boosting regressor algorithm and you will explain it
okay,
to
sir.
the entire everyone.
Oh, okay,
Okay.
sir. Okay,
Uh,
sir.
okay. This is apart from anything that we give you for the main work.
Okay, sir.
Okay. Now, just give me 2 minutes. Am I audible? Uh, Guys, am I audible?
Yes, sir.
Okay, so we are done with you. Next is Rakesh Roshan. Rakesh, are you there with us?
Yes, sir. Yes, sir, I'm there.
Rakesh,
Yes, sir.
uh, Your job will be to explain support vector machines.
Yeah, okay.
Okay. That is for
Now
tomorrow's class.
yeah, okay.
Okay. Don't worry. So one by one, I'll ask you explain all the algorithms that you're using in this place.
Yeah, okay.
So we can see which gave the best accuracy. Generalization 80%, random forest 85.04. Support vector machine only got to 21.84%. How man?
Yeah, I've
This
not
should
used any kernel, sir.
this should give you more accuracy. Put some more work in support vector machines.
Yes, sir. I have not used any
A,
kernel, so
A nearest neighbor 73.12, decision tree 66.71, gradient boosted 88.67. This matrix got okay. Okay. Uh, this is Meghna, do we have you? Meghna, are you there with us?
Yes, sir. Hello.
Yeah, I can hear you. Can you hear me?
Yes, sir, I can hear you.
Meghna,
Sir,
for tomorrow, what you'll have to do is you'll have to explain the difference between ridge and lasso regression.
okay, sir.
Why do we need these two when we already have linear regression?
Okay, sir.
Okay.
Okay.
Linear regression 94. Gradient boosting got you 94%, no?
Yes, sir.
Mr. I gave SVM to Riaz, no? Riaz or Rakesh?
Rohan, Rakesh Rohan.
Rakesh, no? Rakesh,
yes, sir.
this is your score to beat on SVM.
Yes, sir.
87.
SVM is given.
Okay.
Yeah, okay.
Okay. Cheta and Sindhuja still with us, no?
Yes, sir.
Okay, so right now, if we go to projects,
Okay. So first of all, I want everyone to clone this particular repository. Okay. I'll share the link in our WhatsApp group. Okay. As and when you will go through this project, and when you start working on, when you start coding, we will add you as a collaborator or contributor, and when you'll make your commit, your name will come on into this part. So if you just go into this, no, this repository. This is- these kind of commit you will have to meet, and right now those who have assigned diabetic retinopathy, that is Meghna and Rakesh, no? No, Meghna and Riaz. Clone this diabetic retinopathy, and inside this diabetic retinopathy, the first interesting thing that I need you to check it out are these 4 notebooks. Okay. These notebooks are in PyTorch, which is the deep learning library for neural networks. We'll start with deep learning, we'll go into neural networks, but first just explore these 4 notebooks. Those who are on cloud outage, Aryan and Sindhuja. So neither Aryan is there nor Aryan. Are you there with us?
Yes, sir, I'm there.
You are there, no? So Aryan, what I need you to do is go to this. In this cloud outage prediction, first this data it is. Let this data, don't touch it for now. Okay, don't touch the data for now. In this reference, you'll have this 4 research papers. Got this one? Outage prediction diagnosis for cloud services systems. Start reading this paper. See, I don't expect you to build a model right away, but first start reading this paper so that you can come with me for doubt, and we can start working on those doubts together. Got it?
Okay, okay, sir.
So those who are in cloud outage, this is their assignment. Those who are in diabetic retinopathy, it's their assignment. Now we also have someone from traffic analysis, no? That is Bhardwaj and
Yes, sir.
Chita. Chita is also not.
Rakesh, sir. I'm on traffic
Raghav
analysis.
and Rakesh, no? Okay.
Yes,
So
sir.
Raghav and Rakesh,
Yes, sir.
I want you guys to do is, like, we don't have anything as of for traffic analysis yet. We have the data, but we have not uploaded the data to this data repository yet. So till now, what I want you to do is I wanted to explore this particular algorithm, yellow V4. Okay.
Object detection.
Download this and share. I have shared this research paper in the WhatsApp group. Read it and explore it. Okay. What I want in this is that we in traffic analysis will first start with detecting small things like no helmet, wrong side, number plate detection, and smaller stuff. And then we later graduated and integrated this into one bigger model. Okay, so this will be our approach entirely throughout every model that we build. Although there are two students working on one project, they won't be working on the same thing. They will be working on two different aspects of it. Okay.
Okay, sir.
So, Bhardwaj, I have you on agricultural data, na?
Yes, sir.
I have, like, you will be working on the agricultural data analysis.
Yes, sir.
This project is a new project, like, we have not yet started working on this for this cohort.
Okay, sir.
We will get this to you by maybe by tomorrow.
Okay.
But till now, I have not assigned you any other work. No?
Yes, sir.